Hey, welcome. Today we're looking at 2-16 complex numbers. So before we talk about complex numbers, let's just talk about square roots because complex numbers have their foundation in square roots. So if I ask you what the square root of 4 is, then we'd say, okay, that's positive and negative too, right? If we take the square root of a number, we said that it's always going to be positive and negative from now on in algebra. Another way to think about a square root, right? The square root is asking us what multiplied by itself is 4. Right, and we know that 2 times 2 is 4, but we also know that negative 2 times negative 2 is 4 because the two negatives would cancel each other out. Now, what if I asked you what's the square root of negative 4? Well, you might want to say negative 2, right? That makes sense in your brain. But we just said that negative 2 times negative 2 is positive 4. So there's a problem. Negative inside the square root sign. Anytime we have a negative inside a square root sign, there's not going to be a solution. There's no real, so underline real solution here. Okay, so that's where this complex idea comes from. So mathematicians and scientists, they were doing a bunch of calculations back in the day, and they had situations where they had negative square roots or negative inside the square root, and in order to calculate it, it made it a little bit harder for them to work with. But what they said was anytime we have a negative square root, we're going to take that negative 1, the square root of negative 1, and we're going to replace it with I. So the square root of negative 1, they said, is always going to be just equal to I. So that allowed them to simplify. So let's take square root of negative 4. Right? We can rewrite this as the square root of 4 times the square root of negative 1. Right, we're just separating it into two multiplications. Negative 4 is the same thing as 4 times negative 1. Now, this allowed them to calculate this, and they said that, okay, well, we know what the square root of 4 is. That's going to be positive and negative 2. And then we're just going to replace any square root of negative 1 we have with I. So that's what we're going to be doing. Anytime we have a square root with a negative inside, we're going to change that into multiple radicals if we have to. And we're just going to separate the negative 1 from the rest of the inside of the radical. And then we're going to call that square root of negative 1 I. Now, also, since we're at this point, we should probably talk about what happens when we have different powers of I. Okay, so I know that square root of negative 1 is I. I know that I squared then would be the square of the square root of negative 1, but then that's just going to be negative 1. Right, because the square and the square root undo each other. Okay, so then we have I to the third. So what if we write this all the way out? Negative 1, negative 1, negative 1. Right, this is I squared again, right? So that first part is going to be negative 1. And then this is I. So that's just going to be negative I. Negative 1 times I is negative I. Now if we do I to the fourth, then we have negative 1, square root negative 1, square root negative 1. I'm running out of room, square root negative 1. That's I squared again, right? I squared is negative 1, so that's negative 1. That second one is also going to be I squared, which is negative 1. Negative 1 times negative 1 is 1. So we kind of see this pattern repeat itself. If we go on further, let's change this color. let's say we had I to the fifth. So I to the fifth okay, this is going to be I squared, which is -1. There's another I squared, -1. This is just I. So -1 times -1 is 1 times I, which is I. So notice we're back to the beginning here. So if you had to guess I to the sixth, then we just move down again. I to the seventh will be the next one. And then I to the eighth would be 1. Okay, so if you can remember these first four here, actually I should say this first four. I is just I squared is -1, I to the third is -I, and I to the fourth equals 1. Then you can pretty much figure out the rest of them because they just repeat the process. So it's a cycle of 4 before we return to the next one. We'll talk about that more in a little bit. Okay, so the first part is just adding. This is pretty easy. Again, we only add like terms. Like terms. We treat I as any other variable. That's why it's super convenient for those mathematicians and scientists to use an I rather than the square root of negative, or square root of negative number. All right, so 3 plus 4 is 7. -2 plus -5 is -7i. Very simple. All right, just like we practiced before. The next example, we're multiplying two binomials. So we're just going to make sure that we take each part and multiply them to the second parentheses. So we have 4 times 5 is 20. Then we have 4 times 4i is 16i. 3 times 5 is, or -3 times 5 is -15i. And -3 times 4 is -12i squared. Be careful here. Okay, we're going to add these like terms. So 16 minus 15 is 1. So 20 minus 1i, or just I, minus 12i squared. Now, usually we'd stop here, but remember we said from before that anytime we have an I squared, that's -1. So we're just going to change that to -12 times -1. -12 times -1 is +12. And I'm just showing all my steps here. You don't have to when you guys are doing it. So we have the 20 and the 12 now that are like terms. So 20 plus 12 is 32 minus I. Okay, so just remember that I squared is equal to -1. And then go forward from there and simplify. Okay, so this next example, simplify I to the 65. Right, so this goes back to this idea that the numbers repeat here, right? And we repeat in cycles of 4. All right, so remember that number 4. So rather than write this out and figure it out, because no one wants to write I 65 times, that's ridiculous. The easier way to do this is divide by 4. Right, because this is in cycles of 4 for our I. Okay, so 65 divided by 4 is 1. Notice long division is pretty much like polynomial long division. And then we get 6. 6 times 4, 24. Our remainder is 1. So the remainder is the one we're looking for, and that will tell us what our simplified version is. So this would be our exponent. Okay, so let's look back. So I to the, well, there's no 1 here, but I to the first power is I, right? So this whole thing, that whole thing is just going to be I. Okay, so again, first step, divide by 4. Take our exponent, divide by 4. And then whatever your remainder is, that will be your exponent on your I, and that's what you're going to check. Remember, if you have a remainder of 0, though, that would be just like if we had a 4. Or the other way to think about that is anything with an exponent 0 is 1. We kind of talked about that earlier too. Okay, last one, simplify. So you can do this either 2 ways. You can like do the I first, or you can simplify first and then deal with it then. So the thing is, if we have square roots on top and bottom, we can write this as one big square root. And then we can simplify 125 divided by 5, that's 25. And we really don't need the bottom anymore because we divided it. And then we have the negative sign still in there. So what we did was simplify the 5 and 125. We divided those. Okay, and then we're going to do this. We said we can rewrite this as square root of 25 times square root of negative 1. So square root of 25 is positive negative 5. And then square root of negative 1 is I. Okay, and then the last one, this one we can just do, because 15 is not a perfect square and neither is 2, we can multiply these together to make one big one. Negative 30. And then from negative 30, there's no factors that are similar. One way to do this is to do factor tree, right? We can do, I don't need the arrow. We can take factors here. 30 is 6 times 5. 5 is prime. 6 is 2 times 3. Now, if we were to find any pairs, then we could take them outside of the parentheses. But in this case, we don't have any pairs. So negative 30, we can't factor. But what we can write this as is square root 30 times square root negative 1, which is going to be square root 30